Hello, my name is Chelsea Fountain, and I'm here to do my group 3 interactive um, presentation 1 for biochemistry. So the prompt does ask us to explain what the principles are holding the two A helices together. Sorry if I butchered that, but suggest one possible residue that could replace leucerin as indicated by the red star. So the two that the one possible residue, let's first dive into what leucerin, typically what type of amino acid that one is. So what I researched is I found that leucerin is a non-polar hydrofluoric, I hope I pronounced that right, which basically means that it does not like water, and then understand what the side chains are of leucerin. So I started there and tried to figure out what amino acid would kind of be similar to that one. And what I found was a couple of them, but the one I decided to go with was glycine. Glycine, if I'm saying that correctly, I apologize. And that one is also similar to leucerin, is that it is nonpolar and that it does not like water. And the side chain, this will be nice for it to replace because the side chain is comparable to leucerin, where it will actually fit relatively nicely, or it will kind of replace it more smoothly than other amino acids that are out there. And the side chain is only hydrogen. So that is more of a simple, stable amino acid. And I thought that that one would be the best one to replace the leucerin as indicated by the red star in the image that we have on the assignment. So again, it is a hydrophoric core. You saw that in the middle, which means that it does not like water. And the glycine is also similar. And I think that that one would be the best one to go with. Now, the next part of the prompt did ask us, now which one do we think that would destabilize the core? And of course, when you think about that, glycine would come in, replace it. The core will still be stabilized. And the one that I thought that would destabilize the core would be thyroin. Sorry. And it is a hydrophilic molecule. And this one is a strong destabilizer. So, of course, that means that it does like water. Also, that the side chains would not fit nicely and replace and kind of do would not really fit and stabilize. It would kind of destabilize and disrupt the structure of the ladder. So that is the one that I decided that would be the best amino acid that will destabilize the core of this assignment. Now moving on to prompt 2, it did say propose a different amino acid pair whose side chains could interact a similar manner to lysine and glutamate. And of course, I did my research. What is lysine? How does glutamate? How do these two kind of go together? Because they are similar, but they have differences as well. And of course, they both are polar, which they like water, but glutamate is an acid, it's acidic. So if you think of a good way to kind of put it, when you have Velcro, and even though they go together perfectly as a pair, like you have the positive and a negative end, which you have the smooth and then you have the rough end, that the purpose of them is to work together for them to mesh or hold whatever structure together strongly. So I considered all of those factors, and the best one that the two that I thought was one, a basic and polar amino acid is arginine, ARG, and then the aspartic acid, yeah, amino acid. And of course, ARG is the basic, is the polar, it's our more positive, and then a negative one, the asparatic. No, it's not asparatic. It's, I have it written down here. I apologize for asparatic acid. Sorry, and that is the one because it does have that acid component, like the glutamate, and so that would be the perfect pair to. That could be two different amino acid pairs that could work together, like the one lysine and glutamate. So I apologize for completely not pronouncing some of these amino acids correctly, but I hope you enjoyed this presentation and I explained everything well. Okay, thank you.